In this lecture, we'll start off just by talking about what memory is, how people have thought about memory in the past. And we'll look at two prominent metaphors for memory. On the one hand, we'll look at the representational container view, and on the other hand, we'll look at the reconstructive process view. Then we'll turn our attention to the uneasy relationship between learning and memory in the history of psychology and the development of cognitive science. From there, we'll look at our contemporary understanding of memory systems, and we'll use as our framework for this the modal model of memory. And in this particular lecture, we'll look at sensory memory and working memory. In the second lecture, we'll look at the underlying biochemical mechanisms of memory formation and consolidation, and we'll look at long-term memory systems, both declarative and non-declarative long-term memory systems. So in the first part of the lecture here, we'll start by talking about the general notion of memory and the metaphors that people have used to think about memory. Then we'll turn to this uneasy relationship between learning and memory. We'll give a general definition of learning, and then we'll talk about how theorists who think about learning tend to think about memory in terms of a reconstructive process, and hence tend to reduce memory to learning. And we'll see that this is true in behaviorism in particular, where behaviorists don't talk about memory at all, really. They focus entirely on learning. Then we'll give a general definition of memory, and we'll talk about how, as research shifted from psychological schools like behaviorism to representational schools like information-based or computation-based cognitive science, there was a shift from this reconstructive process emphasis, this emphasis on learning, to this representational container notion of memory. And as a result, early on in cognitive science, memories were just thought of as representations, static representations in containers, in systems in the brain. As we'll see, as cognitive science develops, we start to realize that neither of these two metaphors is the complete story about memory, and that memory systems start to involve both reconstructive processes and static representations. So in considering theories of memory, you immediately see two interrelated issues emerging. First, you find disagreement on what constitutes memory. In other words, what are memories? And second, you find disagreement as to the relationship between learning and memory. And specifically, psychologists of the past tended to reduce memory to learning, while current psychology tends to reduce a lot of learning to memory. These issues are related in that notions regarding the nature of memory tend to push psychologists towards one or the other type of reduction. There are two common metaphors for memory. The first one I call the representational container metaphor. According to the representational container view, memories are discrete, static representations stored in the mind. One can find examples of the representational container view as far back as Plato's dialogue, the Theaetetus, in which he models knowledge in terms of impressions made on a ball of wax, or as birds in an aviary. The second metaphor I call the reconstructive process metaphor. According to the reconstructive process metaphor, memories are not static representations stored somewhere in the mind. Memories are recreated or reconstructed by operations of the mind. In effect, memories are created by changing specific processes in the mind. Examples of the reconstructive process metaphor date back at least to Hume's associationist view. So let's start with a general definition of learning. Learning is altered or particularly improved performance as a result of experience. So behaviorists like Watson and Skinner here. For them, learning can be studied by observing changes in behavior, specifically increased probability of a response given a stimulus. And it can be explained by reference to features of that experience that induce such changes through operant and classical conditioning. As a result, on their view, memory phenomenon is just learning. That is, memory just describes the changes in performance that result from experiences. Since they tended to think of memory as the ability to state information and recall past events, memory is really just a subset of learning. And as a result, behaviorist texts tended to have chapters on learning and no chapters on memory. So for instance, Watson's 1914 text, Behavior and Introduction to Comparative Psychology, has no discussion of memory whatsoever. And Watson's Behavior of Organisms, published in 1938, as well as his Science of Human Behavior, published in 1953, also have no discussion, no chapters on memory. So for the behaviorists, memory just was learning. And so there was no discussion of or thinking about or theorizing or experiments about memory specifically. It was all about learning. When neo-behaviorist, particularly Tolman, comes along, and he shows that learning can occur without the sorts of explicit associative experiences that Skinner and Watson employ, there's trouble. And specifically, you'll recall that Tolman discovered that when you present rats with a new maze, they don't just randomly start exploring it as they did with the first maze. They actually start exploring in the direction of where the old goal was. And so Tolman supposes that rats actually learned this cognitive map, this general representation of the relative organization of space, such that their behavior is guided by this static representation that they learned as a result of experience. Now, this led to a lot of studies about memory, how memory was formed and consolidated, and a lot of rabbits were the victims of these studies. So the shift in the way in which learning occurs seems to induce the need for static representations as part of learning. And thus learning can no longer simply and exclusively consist in mechanisms for altering specific processes to change behavior. And memory can no longer simply and exclusively consist in changes in those processes. This shift triggers a move towards the representational container view about memory. We'll pick that up in the next lecture module.